Right. So the driver sitting inside. Now this question is tough. Let us see, right? A driver sitting inside a parked car is watching vehicle approaching from behind with the help of his side view mirror, which is a convex mirror with a radius of curvature 2 meter. Another car approaches him from the behind with a uniform speed of 90 kilometers per hour. So 90 means 25 meter per second. When a car is at a distance of 24 meter from him, the magnitude of the acceleration of the image of the car in the side view mirror. So here we have to find the acceleration of the image, right? Let us see. So side view mirrors are concave mirrors. Sorry, convex mirrors, right? And this is the object which is moving with a speed of 25 meters per second, and it is at a location of 24 meter at this instant. Okay. Radius of curvature is given as 2 meter. We have to find the acceleration, right? Now we know that the distance of the object is changing with respect to the mirror, right? So it means u is variable, v is variable, right? So we can say 1 by v plus 1 by u is equals to 1 by f. So if you want to find the speed of the image, we have to differentiate this. So minus 1 by v square dv by dt minus 1 by u square du by dt will be 0. So dv by dt will be equals to minus v square by u square du by dt, right? From this equation, we can find the speed of the image at this instant. Okay. So let us find the value of v when u is 24. So when u is minus 24 meter and focal length will be 1 meter. So 1 by v plus 1 by minus 24 is equals to 1 by 1. So 1 by v is equals to 1 plus 1 by 24. So that will be 25 by 24. So v comes out to be 24 by 25, right? Okay. So that is v. So from this, we can say it will be minus 24 square by 25 square times 24 square times 25. So that will give us minus 125, right? Meters per second. Okay. So the negative sign indicates that the image is moving in the opposite direction. Now we want to find the acceleration. What is acceleration? So acceleration is nothing but d square v by dt square, right? So what we're going to do? We're going to use this equation. We'll differentiate it one more time. So d square v by dt square will be du by dt is constant, right? Because the object is moving with a constant velocity. So du by dt as it is with a negative sign. Then we apply quotient rule, right? So 2v dv by dt times u square minus 2u du by dt times v square divided by v raised to power 4, right? Okay. Now we have to substitute values. So what is du by dt? That is 25. 25. 2 times v is 24 by 25. What is dv by dt? Minus 1 by 25. What is u square? 24. 24 square. Minus 2, u is minus 24. Du by dt is 25. V square is 24 square upon 25 square divided by 24. This will be u, sorry, this is u, right? 24 raised to power 4. So 25 will get cancelled out. Then 24 raised to power 3 will get cancelled out, right? So we have minus 2 by 25 plus 2 by 25. Is it 25? 25? नहीं, ये तो कट गया ना 25. ये भी कट जाएगा. ये कट गया. Divided by 24. So that will be minus 2. 1 minus 1 by 25 divided by 24. So that will be minus 2. 24 by 25 by 24. That is minus 2 by 25. Is it clear? So that is the acceleration, and we have to find 100 times A. So minus 2 by 25 times 100. So that will be 8, right? So 8 should be the answer. Got it? So this is tough. So this type of question, like I would say hardly like 2 to 3% student will be able to answer this.
We did this in class, I think.
Yes, Mana?
We did this in class. Like, it's not new, right?
It's not?
New.
It's not new, but usually they never ask this question in JEE Mains. So that's why I'm saying it is tough. Right? Okay, right. This question is based on refraction at a spherical interface. So which formula we have to use in this question? Mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. Okay. Let us see the question. Two concave refracting surfaces of equal radii of curvature and refractive index 1.5. So this is 1.5, 1.5. Face each other in air as shown in the figure. A point object O is placed midway between P and B. So this is P, this is B. The object is placed midway between P and B at the midpoint of PB. The separation between the images of O formed by both the refracting surfaces, right? So first let us try to find the position of the image formed by this refracting spherical interface. Let me call this 1. Here we have 1.5 and there is an object. Now the distance of the object from the center of the interface is r by 2. Rays are going in the right direction, right? So what is u in this case? Who can tell me what is u? We have to measure distance from the center of the interface, right? From B. Minus r by 2. Why negative? Because we are measuring object distance against the direction of incident ray, right? Okay. And what is mu2 in this case? What is mu2? Mu2 is the refractive index of the medium of refraction. The refracted ray is in glass. So mu2 will be 1.5. Mu1 is the refractive index of medium of incidence. Here it is air, 1. Okay. And R, radius of curvature, is it positive or negative? Radius of curvature.
Negative.
Negative, because center of curvature will, this is the center of curvature P. And it is, if we want to measure the radius of curvature, we have to travel in against the direction of incident rays. So it has to be negative. So here we have to take R as minus R, right? Now let us substitute these values in this formula. So mu2 is 1.5 divided by V minus 1 divided by U, which is minus R by 2, is equals to 1.5 minus 1 divided by minus R, right? Okay. So 1.5 is equals to minus 2 by R minus 0.5 by R. So that will be minus 2.5 by R. So 3, 5. So R will be minus 5 by 3, right? Okay. Minus 5 by 3. And this will be in minus, मैंने क्या कर दिया, सॉरी, यहाँ पे v है. V will be minus 3 by 5 R. So that will be minus 0.6, right? Okay. Now let us see the left interface. Second one. This is the object. The distance of the object from the center of this interface. What is this distance? What is AO? Yes.
Minus
What is 3 by 2 R, right?
E by 2. Why?
This is R by 2.
अच्छा, object is okay.
This is R, right?
Right.
Here, 3 by 2 R. Okay, now the rays are going in the left direction, right? This is the direction of incident ray. So what is U in this case? Yes, what is U?
Still negative. Right?
Yes,
Still negative.
negative, minus 3 by 2 R. Okay, what is mu2?
1.1.
1.5, mu1 will be 1. So let us apply the formula one more time. So 1.5 by V minus 1 by U will be minus 3 by 2R. 1.5 minus 1 divided by, what is R in this case, positive or negative?
R is also negative.
Negative, right? Because we have to, in order to measure the radius of curvature, we have to travel in the right direction from A. So minus R. So 1.5 by V minus or plus 2 by 3R is equals to minus 0.5 by R. So 1.5 by V is equals to minus 2 by 3 minus 1 by 2 times 1 by R. So that will be minus 7 by 6 R. So V comes out to be minus 1.5 times 6 by 7 times R, right? That will be 9 by 7, right? Okay. And it comes out to be minus 1.268 405, right? 1.285 something, right? Times R. And it is minus 0.6 R. So if I draw A, B, this is O, right? V, in the first case, V is negative. It means the image is formed on the same side of the object, right? Where we have the object. So in the first case, it is 0.5. So if I show the image 1, so this distance is 0.6 R. In the second case, again, we are getting negative. It means the image is formed on the same side as the object. And it will be 1.285. Right? So this distance we have to calculate. Is it clear? So what is I1, I2?
2R minus the sum of.
Right. So that will be 2R minus 1.285 R minus 0.6 R, right? So that will be 1.885. So 0.114. So this should be the answer, right? Okay. Clear? Right. So I would rate this question as moderate, right? Because lots of calculation. Okay. A spherical surface of radius of curvature R separates air from glass. Refractive index is 1.5. The center of curvature is in the glass. So we have given this is the center of curvature and this is glass. And radius of curvature is R. A point, an object O placed in air. So here we have air on the optical axis of the surface so that its real image is formed at I inside glass. Let us say there is an object O. The line OI intersect the spherical surface at P and PO is equals to, okay, right. So let us say this is the image and this is P and these two distances are equal, right? Okay. So if this is X, this is also X. And we have to find X, right? So here what we can do, rays are going from right to left. So this is the direction of incident ray. So U in this case will be minus X, V is plus X, R will be plus R, and mu1 is 1 and mu2 is 1.5. So we're going to use mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. So mu2 will be 1.5, V is x minus 1, x, U is minus x. So 1.5 minus 1, and R in this case, we have to, in terms of R, we have to calculate, right? So that will be plus R. So 1.5 plus 1 by x, 0.5 by R. So this will give us 5. So x will be 5R, right? Option. Got it? Clear? So again, I would rate this as easy question, right? Formula, direct formula based question. Given a thin convex lens refractive index mu2 kept in a liquid of refractive index mu1, and we have given mu1 is less than mu2. Having a radius of curvature r1 and r2, its second surface is silver polished. Where should an object be placed on the optical axis so that the real and the inverted image is formed at the same place? Okay. So we have given a convex lens, refractive index is mu2, and there is a liquid of refractive index mu1. Radius of curvature is also given. This is r1, this is r2. Its second surface is silvered polished. Where should an object be placed on the optical axis so the real and inverted image is being formed? So it means this combination will behave like a mirror. And if we place the object at the center of curvature, the image will be formed at the center of curvature. Is it clear? Okay. So here we have a combination of a lens and a mirror. So we can say effective power will be 2 times the power of lens plus 1 times the power of mirror. Is it clear? Same formula we have to use. So 1 by FL, focal length of the lens, will be mu2 by mu1 minus 1 times 1 by R1 plus 1 by R2 in this case, right? Is it clear? Okay, right. So now what we can do? So this can be written as 2 times mu2 by mu1 minus 1 times 1 by R1 plus 1 by R2. Plus, in case of a mirror, power will be reciprocal of the focal length. So that will be 2 by R2. Is it clear? 2 by R2. Now we have to simplify. 2 times mu2 minus mu1 by mu1 R2 plus R1 by R1 R2 plus 2 by R2 R1 mu1 R1 mu1, right? So this will be 2 times mu2 R2 minus 2 times mu1 R2 plus 2 times mu2 R1 minus 2 times mu1 R1 plus 2 times mu1 R1 divided by mu1 R1 R2. Which term is getting cancelled out? Mu2. Mu1 R. These two terms, right? And we have to, and this will be 1 by F effective, right? And if I multiplied this with 2, basically we have to find 2 times F effective, right? That will be the radius of curvature. So, so let us take this 2, cancel this. So we are getting mu1 R1 R2 upon mu2 R1 plus mu2 R2 minus mu1 R2, right? Mu2 they have taken together, no? Right. Clear? So option D is the right answer, right? I hope this is clear. So I would rate this as moderate. Why moderate? Because of calculation. Given a thin convex lens of glass of refractive index mu and each side having a radius of curvature r, one side is polished for complete reflection at what distance from the lens an object be placed on the optical axis so that the image gets formed on the object itself. So it means the effective combination, effective mirror, we have to place the object at the center of curvature, right? Same logic. So here we have a lens, biconvex lens, and this we have silvered this. So this is nothing but a converging lens and a converging mirror, right? So the effective power will be 2 times the power of lens plus 1 times the power of mirror. So this will be 2 times mu minus 1 2 by r plus 2 by r, right? 2 by r. So this will be 2 times 2 by r. Okay, right. And we have to find that will be 1 by f effective. So multiply this with 2, right? So this will be 1 by r effective. So 2 mu minus 2 plus 1 divided by r. So that will be 2 mu minus 1. 2 mu 2 by r. Right? So it should be r by 2 mu minus 1, right? Clear? Clear na? I hope this is clear.